So today we are continuing this Pipecat series about frames, and this is the third video about frames. Today we are gonna be talking about control frames. What are control frames? Why it is there? And in the previous two videos we discussed about system frame and data frame. So I'm gonna first come back to this example where we discussed about uh, uh, what exactly is a frame and system frame, data frame, control frame. In this diagram we saw system frame is of high priority and data frame and control frame are of low priority. So in the last video we discussed about data frame and what data frame is. Mainly data frame is used to carry the data, and if you leave this part about data, system frame and control frame are almost exactly the same, except they are not about data. But why did we need the distinction to create a high priority and low priority? So I'm gonna be again discussing a few examples of system frame. So in the system frame, if you remember, we had like kind of start frame, error frame, and then we have interruption frame, and then we had other bad users started speaking frame, and all of those frames. So if you see all of those frames, they are like examples of frames which are of high priority. Like this is something, if a system receives in the starting, like it would enable the system to either start doing something or stop doing something, or a signal which should be prioritized ahead of all the other tasks, so all the other frames. So that's why we needed to create a priority. So that's why system frame is something which is of high priority and control frame are of a low priority. So coming back to this, control frames orchestrate the pipeline behavior. They don't carry user data, they control the flow, state, and life cycle. Some part system frame is already doing, but they are of higher priority, and control frame is of lower priority. And why they are useful, like they enable clean boundaries between services, and they allow runtime control without restarting pipelines. So we have different types of control frames, like lifecycle control frame, LLM response control frame, LLM thought control, TTS control, function calling control, service settings, audio processing, processor control, service switcher. So all of these different types of control frames we have, which we are going to be discussing today. And just to talk a bit about who uses them, so pipeline, orchestrator, LLM, TTS, STD service, all of them uses based on the type of frame. So key idea is control frames are the traffic signals of Pipecat pipeline. Like next we have types of life cycle frames. So we have this end frame, stop frame, output transport, ready frame, heartbeat frame. So all of these are different life cycle frame. So start frame was also a life cycle frame which is of higher priority, that's why it is a system frame. But all these different frames are of low priority, that's why they come under control frame. So next we have end frame, and end frame is something which helps us in graceful shutting down the pipeline. So it signals intentional pipeline termination, like when end frame is received, all the processors stop, they clean up, and then it gets shut down. So it's kind of like when you are shutting down your system, like you have restart option, you have shutdown. So it is kind of like a shutdown option. So it is for normal pipeline termination, user disconnection, and all of this. So now we use this queue frame. So all the life cycle, so these life cycle control frames, all these frames, and along with the start frame, these are life cycle frames, and they are coming from an external system. That's why we always queue them. So that's why this pipeline is basically a pipeline task. So pipeline task dot queue frame and frame. So this is how we queue them. So this distinction between queue frame and push frame is something that we are going to discuss in detail when we are discussing about pipelines. But right now you can just understand that queue frame is something which is coming from an external system, and all the different life cycle frames, start frame, end frame, stop frame, output transport ready frame, and heartbeat frame, whichever is the lifecycle control frame they are using Q frame. So next we have stop frame. So stop frame is kind of like pause without destroying. Stop frame processing stops the frame processing without tearing down processors. It is useful for pausing and resume workflows, and saves expensive resources like LLM, TTS, state. So we can kind of pause it and then resume it without destroying the processor. So again, we are queuing this frame and it pauses it. Then we have output transport ready frame. So this is a push frame. Sorry. So this is not Q frame, but this is a push frame, and it basically it signals readiness. Um, uh, so it signals output transport is ready to receive frame. So it prevents lost or dropped output, and it synchronizes pipeline start with transport availability. So when the transport is available, it synchronizes the pipeline start with it. And it's kind of used by output transports and downstream processors. So basically signals that output transport is ready to receive frame. That's it. So this is about that, and then we have heartbeat frame. So now heartbeat frame is again a push frame. It's it's basically monitor pipeline health. So as the name suggests, heartbeat periodic signal that pipeline is alive. And it is useful because it detects stalled or dead pipelines, and it enables monitoring, and it is used for long running sessions and production deployment, and it is mainly used for monitoring. So that's why we have this heartbeat frame, and any processor when we want to monitor, so we are pushing that frame and sending it. Right. Then coming to LLM response control frame, we have all of these four types of control frames. We had one data frame, like different data frames that we discussed in the previous video. So today we are going to be talking about the control frames related to LLM response, which is first one is LLM full response start frame. As the name suggests, LLM full response start frame is something which is kind of like the beginning of the, it marks the beginning of the LLM response. And it is useful because it defines the response scope, and it is used before emitting LLM text frame. So and it has certain properties like whether we want to skip the TTS response or not. So this is something we can use to LLM for LLM full response start frame, and then skip the, and we can push it. Skip the TTS and push it. So and then as you can see, we have also have full response end frame, which is we are gonna come next, which is like it marks the end of the LLM response. So it's kind of like a start LLM full response start frame, then LLM text, and then response end. So any other processor can do the next set of thing. So we are again pushing it, and the end frame, and then it is received by the next processor. And it is mainly useful for conversation control, like so that's why like start and start text frame, and then end frame. Then we also have vision full response start frame, and vision full response end frame. So with respect to vision frames, like in the vision text frame, if like before start like sending this vision text frame, internally we send the full response start frame and full response end frame. And this is like it is send one by one. So like start, then vision text, and then end frame. So similar to LLM start end, we also have vision start and end. Then we have this example. So as I said again, before sending LLM text frame, we send LLM full response start frame, and then whatever is the response by LLM, we send it one by one with interspacing, and like interspacing is already there, so it already aggregates it like hello comma world, and then we are sending that this is the end of the LLM response. So it is generally received by aggregator or some other processor after LLM, and then it does whatever it wants to based on these different frames. So yeah, then we have LLM thought frames. So types of LLM thought control frames, we have these three. Again, start, end, and then thought text. So you can see this pattern in all of these different frames. Like these are defining the boundary. Like this is the start, this is the end, and this is in between. We are sending all the text. So similarly, thought start frame, thought content, and then thought end frame. Then it is sent to the processor. So this thought is something LLM internal reasoning, like what the LLM is thinking about and all of that. So we create this LLM thought start frame, and the model, and append to context, and all of this. So this is the thought start frame. Then this is the thought text frame, where it is the text chunk of LLM thought, and it is not a data frame, uh, because thought is something internal for the LLM. So we don't want whatever LLM is thinking to speak it out to the user. So that's why, although it contains the data, but this is not a data frame, it is a control frame. So this is the exception, some exception that you need to keep in mind. But yeah, generally it is not that useful. So yeah, so data frame, not text frame, and to avoid TTS processing. So we have this import, and then LLM thought text, whatever text, and then we are pushing it. And next we have thought end frame, end of LLM thought. As we have explained, we are importing, and then thought end frame, whatever it is, and then we are pushing it. Then we have TTS control frames. So now TTS control frames are TTS started and TTS stopped. So it is kind of like to know when audio generation is beginning and when it is stopping. So beginning of TTS audio generation, so start and then stop, and in between we have this audio raw frame. So similarly importing and then pushing it, and then followed by TTS audio, and then end. And similarly then stopped, same, importing it, it marks the end of the TTS audio generation, importing it, and creating and pushing the frame, and yeah. So TTS flow is like a, so yes, coming to this TTS flow, before TTS start and TTS stop, we have this TTS audio, and this TTS start frame is generally, before that we have this TTS text frame. So text frame uh, is when this TTS received this TTS text frame, then only it internally start like sending it itself a start frame, then TTS audio frame, and then TTS stopped frame. So flow is like once the text is received, the TTS text frame is received, then TTS start frame, audio raw frame, different audio frames, and then based on the response, and then TTS stopped frame. Based on the text, we generate this audio, right? So this is how the flow. Once the text is received, then TTS started, and then TTS end, and in between we have this audio frame. And this is the working, this is the code example for the same. And next we have function calling controls frames. So function calling control is something that we discussed a lot. So I'm just gonna check over here just a second. Yeah, so in SystemFrame we discussed about function call. So I want to come to this diagram. So function call started frame, function call in progress, and function call result frame, function call cancel frame. So function call started and function call cancel is the system frame. So function call in progress is the control frame that we discussed over here. So call in progress frame is the control frame, and it is the uninterruptible frame. Function called result frame is also data frame, and this is the again uninterruptible. So I'm just gonna come to this diagram. So LLM, when it starts the calling, so function call started frame, and then call is in progress. It is making API call, response is received, and this is carrying the result. So that's why this is the data frame, and function call cancel is again a system frame. So call start, call end uh, is a system frame, but call in progress is a control frame. So coming to this function call in progress, it signals that tool or function call is executing, and it is useful because it protects critical operation, prevents partial execution, and we and that's why it is a uninterruptible frame. So everything will get written, but this will stay. So in case of interruption, so call in progress and uninterruptible, and then next step. So yeah, so we have already discussed in the diagram. This is the better diagram for function call started, call in progress, and then call result, and function call cancel. So call in progress is here. Yeah, you can see the example by yourself. And then coming to service setting frames. So service setting is it basically updates update the service behavior without restarting. So if you want to make any setting changes to LLM, TTS, STT, we can use these frame to update those service settings without restarting it. So for example, if you want to update LLM service setting, like update the temperature, tokens, or anything, we can use this. Then we have TTS update settings frame, which is update the TTS service setting, like update the TTS voice, speed, or anything. We can use this. STT again, changing the language, punctuation. We can use this to update the settings, and basically they are useful for dynamic adaptation and user preferences experimentation. So this is again one example where we are updating settings, TTS update setting, TTS component, and WAD param update frame. So this is something we are going to discuss next. It does not come under this setting. So it comes under audio processing control frame. So we have WAD param update, filter update setting, filter enable, mix update setting, mixer enable. So all of these are related to audio. um, Next, sorry. So as the name suggests, WAD param update frame, they are runtime control for audio behavior to update the WAD parameters. So we can update the WAD parameters like that and push it ahead. Then we have filter update settings, update audio filter settings like noise reduction, gain. Based on the filter update, we can update the filter using this frame. And then filter enable is like in case we want to enable the filter or disable it, we can do that by enabling and disabling it, and filter is enabled and disabled. Then mixer update setting is something like based on the setting we can update the mixer, update audio mixer settings. So these are related to that. And then we have mixer enable frame, again enable and disable it. Yeah. So next we have process control frame. So process control frames are they pause or resume a specific processor. So we have this frame processor pause frame. So um, if we want to pause frame, uh, uh, pause frame processing for a specific processor, we can do that. So if we use this, then next processor is paused, and then it goes to the next processor. So and resuming is for resuming it. So this is how the this process frames work. Then we have service switcher. So in case you want to switch certain services, so we have this service switcher control frame. So manually switch service frame. We if you want to, let's say, switch from one LLM to some alternate LLM, so we can use this manually switch service frame, and we are pushing it. So yeah, you can see this. So coming to the key takeaways, so we have discussed different types of uh, uh, control frames, and control frames, as you can see, it basically mostly a start and stop frame. So it's like a it control frame manages the flow and settings, like it is either updating the setting or managing the flow in the pipeline, what is starting, what is ending. So it signifies that. And it is low priority but maintaining order. So it is less priority than system frame, but it is maintained in order. uh, and as I said, it start and end pair mark response boundaries, like we have start frame and response generation. Then we also update the settings. Certain frames were uninterruptible, so we have to keep that in mind. And then processor control for pause and resume, updating setting and pausing resume, and start and boundaries. So these are the few things that need to keep in mind for this control frame. So in the next video we will be talking about processors in detail. What are the different types of processors, filter processor, aggregate processors. um, so all of these processors we are gonna discuss in detail in the next video. So thank you for watching. If you like the video, please like, share, subscribe. Thank you.